In this video, we'll take a look at the asymptotes and zeros of more complex rational functions that are not in transformation form. The very first thing I want to do with this function is to find the zeros. When I'm finding the zeros, I'm asking, where does this function touch the x-axis? So I'm trying to find the x values of this equation where y equals 0. If I want my output to be 0, the numerator of my function has to equal 0. So to find my, quote, zeros, we will set the numerator equal to 0. So I'm going to go ahead and take my numerator and try to find out where it equals 0. In this case, my numerator has to be factored before I can solve for x. So I'm going to take x squared minus x minus 2 equals 0, and I'm going to go ahead and factor that expression. I'm going to find two things that multiply to negative 2 that add to the negative 1 coefficient of x in the middle. Those numbers are 2 and 1, and if I want a negative 1 when I add them, the 2 has to be negative. So here's my x minus 2 and x plus 1 equals 0. Now I'm ready to go ahead and solve for my zeros by setting each of these factors equal to 0 one at a time. If x minus 2 equals 0, x will be positive 2. If x plus 1 is 0, x will be negative 1. These are the two x values where my function will touch the x-axis. So x equals 2 and x equals negative 1. Up next, I'm going to find my vertical asymptote. My vertical asymptote is not a value where my function will touch the graph. It's a value where my function will never be able to reach an x value. The only reason we wouldn't be able to use an x value is if it breaks our equation in some way. In this case, the only way to break our equation is to try to divide by 0. So for a vertical asymptote, I need to see what would make me try to divide by 0. I'm going to take my denominator and set it equal to 0. So I'll take x minus 1, and I will set it equal to 0. I will add 1 to both sides, and the x value that would make me try to divide by 0 is x equals positive 1. So x equals positive 1 is going to be a value that I am not allowed to use. So every time I label an asymptote, I will label it with a does not equal sign. Last but not least, I'll take a look at my horizontal asymptotes. I'm going to start abbreviating here. We learned that there are 3 types of horizontal asymptotes. There's 0, y cannot equal 0 if my denominator has a higher degree than my numerator. There's a slant asymptote if my numerator has a higher degree than my denominator. And there is a fraction of the leading coefficients if my degrees are the same. All I have to do to find this one is to take a look at the degrees on top and bottom. The degree of my numerator is 2. That's the highest power of x. The degree of my denominator is 1. Because I have a higher degree in the numerator than the denominator, I have a slant asymptote. So I just write the word slant, and I'm done. Let's go ahead and take a look at question 23. Same type of question. We'll identify the zeros and the asymptotes. First, we'll start with the zeros. Again, to find the zeros, all I have to do is set the numerator equal to 0. 12x minus 5 equals 0. This will tell us the places where my function touches the x-axis. I'll add 5 to both sides, so 12x will equal positive 5. And then I'll divide both sides by 12. X is going to equal 5 over 12. So that value, which is just slightly less than 1/2, that is where my function touches the x-axis. Up next, I'd like to calculate my vertical asymptote. To find my vertical asymptote, again, I have to figure out where my function will break. And where my function will break is all the places where my denominator equals 0. So I'll take my 3x minus 6, and I'll set that equal to 0. All we have to do is unwrap x by moving everything away from it, so we'll add 6 to both sides. 3x will equal 6. We'll divide both sides by 3. 6 divided by 3 is 2. The number 2, if I plug that into my denominator, it will make me divide by 0. So I am not allowed to use the number 2. Up next is the horizontal asymptote. Again, we have those three cases, and we just have to look at the degrees of the numerator and denominator to figure out which case we have. The degree of my numerator is 1. I have x to the first power. The degree of my denominator is also 1. I have x to the first power, which means in this case, my horizontal asymptote will go toward the fraction of the leading coefficient 12 divided by the leading coefficient 3. I can actually do 12 over 3, which means the y value that I'm going to be getting close to but never reaching is 12 divided by 3, which is 4. And that's it. That problem's done. Let's go ahead and try the last example of calculating the zeros in vertical asymptote. Here we go. We'll start with the zeros, the places where we touch the x-axis. We'll take our numerator, x minus 3, and set it equal to 0. We'll add 3 to both sides, and we'll find that this function will touch the x-axis at x equals 3. There we go. Up next are vertical asymptotes. So here's my denominator. This is what will break my function. So I need to take my x squared minus 4, set that equal to 0 to find out what x values I'm not allowed to use. Now I could start unwrapping x, but it's better to factor first. And this is a difference of squares. So x is being squared in front, 2 is being squared in back, which means our factors are going to be x plus 2 and x minus 2. Now I can find both values that x will be. Set each one equal to 0. X plus 2 is 0. X is negative 2. And if x minus 2 is 0, we add 2 to both sides. X is going to be positive 2. Those are the two values that will break my function. If I plug in either one of those, I will end up trying to divide by 0. That means that x is not allowed to equal negative 2, and x is not allowed to equal positive 2. Last but not least, I have my horizontal asymptote. My horizontal asymptote happens depending on what case I'm looking at. So the degree of my numerator is 1. The degree of my denominator is 2, because I have x to the second power. The denominator is larger. The bottom will get bigger faster than the top. This is just like taking a cake and cutting it into more and more and more and more pieces. The larger the denominator gets, the closer I get to having 0 as a final solution. The closer I get to having no cake for each person. So because my bottom's getting bigger, the y value we're getting close to is going to be 0. That's it for this question. All we have to talk about next is identifying holes in functions and graphing them, so that will be our last video.